Hello, students, and a very warm welcome to today's explainer class. I'm so glad you could join me. Today, we're diving into something truly fascinating. We're going to explore the real-world applications of trigonometry. Specifically, we'll see exactly how we can measure towering heights and vast distances without ever needing a giant measuring tape. It's quite magical, really. Let us begin.
Created by Mindsticks Foundation Test.
Here is our agenda for today's lesson. 1. The magic of trigonometry. 2. Understanding your angles. 3. Solving for height. 4. Solving for distance. And 5. Practice makes perfect. Let's jump right in. Section 1. The magic of trigonometry. Have you ever wondered how we measure things we simply cannot reach physically? Think about a towering skyscraper, a massive tree, or a ship far out at sea. We certainly don't use a giant ruler, do we? Instead, we use mathematics. If we need to know the height of a tower or how far a ship is from a lighthouse, we can easily calculate these measurements using trigonometric ratios. To do this computation, we simply draw a rough sketch, treating vertical objects like trees or buildings as perfectly perpendicular straight lines to the ground.
Section 2. Understanding your angles. Before we start calculating those distances, we need to build our core vocabulary. The absolute first term we must understand is the line of vision. Imagine you are standing at point A, looking directly at a specific object at point B. That imaginary straight line drawn directly from your eye to that object, that is exactly what we call your line of vision.
Now, what's really interesting is how this line of vision interacts with the horizontal plane. Suppose you were looking up at an object, meaning it is at a higher level than your eyes. Imagine a horizontal line drawn straight out from your eye level. The angle formed between that flat horizontal line and your upward line of vision is what we call the angle of elevation. So let's lock in this definition right now. The angle of elevation is the angle formed when the object being viewed is strictly above the horizontal level. Simply put, whenever you tilt your head upwards to look at something, you are creating an angle of elevation. Now, consider the exact opposite situation. Let's say you are standing on a high balcony, looking down at a car parked on the ground. When we draw our horizontal line straight out from your eye level this time, the angle formed by your eyes looking down is called the angle of depression. To solidify our definition here, the angle of depression is formed when the object being viewed is below your horizontal level. Just remember this simple rule. Looking up gives you an angle of elevation, and looking down gives you an angle of depression. It really is that straightforward.
Section 3. Solving for height. Now that our foundational concepts are perfectly clear, let's apply them to solve actual problems. Whenever you face these word problems in your exams, just follow 3 simple steps. Step 1, draw a rough sketch, always making sure to represent your height as a vertical perpendicular line. Step 2, identify whether you are dealing with an angle of elevation or an angle of depression. And step 3, apply the correct trigonometric ratio. For most of these practical cases, the tangent ratio is going to be your absolute best friend.
Let us see this in action with an example. Imagine an observer who is standing exactly 10 meters away from the base of a tree. They look up at the very top of the tree, and their angle of elevation is 60 degrees. Our task is to find the total height of this tree. If we picture our sketch, the tree is our perpendicular vertical line, and that 10-meter distance along the ground is our base. Let's calculate this methodically together. Our base distance is 10 meters, and our angle of elevation is 60 degrees. Now, we know from our formulas that tan 60 equals the opposite side divided by the adjacent base. And if you recall from your trigonometric tables, the value of tan 60 is the square root of 3. So our height divided by 10 equals root 3. To isolate the height, we multiply both sides by 10, meaning our height is 10 root 3. If we use the standard value of 1.73 for root 3, we get 10 multiplied by 1.73, and that gives us exactly 17.3 meters. So the height of the tree is 17.3 meters. Very simple and logical, correct? Section 4, Solving for distance. Excellent work so far. Now we will use this exact same perspective to calculate how far away an object is located, rather than how tall it is. Imagine an observer standing at the top of a building that is exactly 40 meters high. They are looking down at a parked scooter on the ground, creating an angle of depression of 30 degrees. We need to find exactly how far that scooter is from the base of the building. Let's break down the mathematics. The building's height is 40 meters, and the angle of depression is 30 degrees. Now, here's a crucial geometry trick you must remember. The imaginary horizontal line from the observer's eye is parallel to the ground. Because of this, the angle of depression and the angle inside our triangle at the ground level are alternate interior angles. And as we know, alternate angles are always equal. So, our interior angle from the scooter looking up is also 30 degrees. We use tan 30, which we know is 1 divided by root 3. So 1 upon root 3 equals our height of 40 divided by our unknown distance. We cross-multiply, and our distance becomes 40 times root 3. Let's do the math. 40 multiplied by 1.73 gives us 69.20 meters. The scooter is exactly 69.20 meters away from the building.
Section 5. Practice makes perfect. I truly commend you all for following these calculations so attentively today. But remember, mastering mathematics requires consistent, dedicated practice. So, here is an independent exercise for you to try at home. A kite is flying at a height of 60 meters above the ground. The string makes an angle of 60 degrees with the ground. Assuming the string is perfectly straight, what is the total length of that string? I highly encourage you to apply the 3 steps we just learned. Draw your rough sketch, carefully identify the angle, and choose the correct trigonometric ratio. Give it your best attempt. Thank you so much for joining today's explainer class. Keep practicing, keep solving, and keep learning.